Dear students, today's topic is work. When is work said to be done in physics? Work is said to be done when a force is applied on an object and the object moves through a distance. Look at the figure given here. The force F is applied in a direction at an angle theta with respect to the horizontal, and the displacement is along the horizontal. So we know that force is a vector, and since it is making an angle with respect to the horizontal, the force can be divided into rectangular components. Now F is divided into F cos theta along the x-axis and F sin theta along the y-axis, which means F cos theta is parallel to the displacement and F sin theta is perpendicular to the displacement. It's in comparison with the above diagram. So we can see that a component of force is parallel to the displacement and another component of force is perpendicular to the displacement. Now F cos theta is parallel to the displacement. So component of force in the direction of the displacement is F cos theta. Work done by a constant force on a system is the product of the component of force in the direction of motion and the distance through which the force acts. Mathematically, we can put whatever is the message produced in this statement can be put as W equals magnitude of the force into cos theta into magnitude of the displacement. Here theta is the angle between the force and the displacement. It gives us W equals Ft cos theta. Now W equals Ft cos theta is the general expression for work done. You can apply this formula in any situations. Now, when we apply this formula in different situations, we get different types of work. Let us analyze the different types of work. Case 1. Positive work. Look at the diagram here. You have an object which is placed at the position A, whose center is placed at the position A. A force is applied on it and the object is moved to another position B. So the displacement D is parallel to the applied force. A force F is applied on an object. The object moves through a distance from A to B in the direction of the applied force. So when two lines are parallel, what is the angle between them? The angle between two parallel lines is 0. Similarly, the angle between the force and the displacement here is 0, since force applied is parallel to the displacement. So we get the equation W equals Ft cos theta. The general equation is changed to W equals Ft cos 0. We know that cos 0 equals 1. So W equals Ft, which is positive work. So to conclude, work done is positive when the force and the displacement are in the same direction. So whenever you have force and displacement in the same direction, you can directly apply the formula work done equals force into displacement. So then what happens if the force and the displacement are not in the same direction, like they are in the opposite directions? Let us look at another situation. Negative work. Here in the diagram, the object whose center is at A is displaced to a position B and the displacement is D. A force is applied which causes this displacement. Now we have frictional force which always acts opposite to the direction of motion. If the surface is rough, the frictional force will be high. So here the frictional force is acting in a direction opposite to the direction of the displacement. Now there are two situations here. One, the force applied and the displacement are in the same direction. Two, the force applied and the frictional force are in the opposite direction, or the displacement and the frictional force are in the opposite directions. So the work done by the frictional force on the object, the general expression is Ft cos theta. Here what is the angle between the frictional force and the displacement? Since they are opposite, the angle has to be 180 degree. So the work done is Ft cos 180 degree. Cos 180 degree is -1, which means W equals minus Ft, that is negative work. So the work done by the frictional force on the object is negative. Here we also have work done on the object by the applied force as positive. So in this case, it depends on the positive and negative work identification depends on the force involved. So if the question is, what is the nature of the work done by the applied force? Your answer to it is positive work, because the force applied and the displacement are in the same direction. But if the question is, what is the nature of work done by the frictional force? Then the work done by the frictional force on the system is negative, since the displacement and the frictional force are in the opposite directions. So then what if the force and the displacement are perpendicular to each other? So we have another situation where the work done is perpendicular to the displacement. Look at the situation here. The object is placed on a surface. A force is applied towards the right and the displacement happens towards the right, which means force applied and the displacement are in the same direction. Now the friction is acting opposite to the displacement. The gravitational force is acting vertically downwards, which means it is perpendicular to the direction of the displacement. So here we know that from the previous situations, the work done by the applied force here is positive, since the angle between the force applied and displacement is 0, or they are parallel to each other. And also we know that work done by the frictional force on the system is negative, since the frictional force and the displacement are opposite to each other. Now what is the work done by the gravitational force on the system? Here the general formula is Ft cos theta, which means W equals Ft cos 90. Because gravitational force is perpendicular to the displacement, the angle between them is 90 degree. So cos 90 is 0, which means work done is 0. So here you see the situation that whenever the force is perpendicular to the displacement, the work done on the system by the force is 0, whereas work done on the object by the applied force is positive and work done on the object by the frictional force is negative. So again we can conclude that it depends on the force that is involved to conclude whether the work done is positive, negative or zero. Now, what are the situations, different situations under which work done is zero? Work done is zero when there is no force, or there is force applied but the displacement is zero, or when force is perpendicular to the displacement. Take the case of circular motion. You can see that in a circular motion, the centripetal force is always along the radius inwards, and the direction of velocity, linear velocity, and the displacement is tangential. Now the tangent is always perpendicular to the radius. So in this case of circular motion, at every point of the motion, the force and the velocity, or force and the displacement, are perpendicular, and hence work done by the centripetal force on an object moving in a circular path is always zero. So with this we come to the end of this today's session. We will meet with another topic which deals with the consequences of positive, negative and zero work. Thank you.